Everyone, welcome back to the third video lecture series of 8086 architecture. So coming to the previous review, I just want to recall. So we saw that the architecture of 8086 consists of two units. One is bus interface unit and the other one is execution unit. And in the bus interface unit, there are four segment registers: the code segment, data segment, extra segment, and the stack segment. These segments are help in calculating the address from the memory, and that is calculated using a formula, which is nothing but the physical address is equal to segment registers into into 10 plus offset registers. So using this physical address, the 20-bit address is being given to the memory, and the instructions are being fetched from the memory, and it is queued in the 6-bit prefetch instruction queue. And from there, the instruction will be decoded using the control system, and then it is sent to the execution unit. So the execution unit generally consists of the four general purpose registers, which are AX, BX, CX, and DX. Each are of 16-bit registers, and few offset registers, nothing but SP, BP, SI, and DA. So there is an ALU unit, that is arithmetic and logic unit, in the execution unit, which is used to perform the instructions or the operations in the execution unit. So now moving into the different type of general purpose registers. So let us see about each register in detail. So now coming to the accumulator registers, or the AX. So this consists of two 8-bit registers, AL and AH, which can be combined together and used as a 16-bit register. AL in this case contains the lower order byte, and AH consists of the higher order byte. The input-output instruction uses the AX or AL for inputting and outputting 8 or 16-bit data from an input-output port. The multiplication and division instructions also use the AX or AL. Now coming to the next registers, that is the base registers BX. So this consists of two 8-bit registers BL and BH, which can be combined together as a 16-bit register and denoted as BX. Here again, BL consists of the lower order byte and BH consists of the higher order byte. Combined together, it can be used as the 16-bit register. This is the only general purpose register which is used, or whose contents can be used for addressing the 8086 memory. All memory references utilizing this register content for addressing uses DS as the default segment registers. The counter register CX. This consists of two 8-bit registers, CL and CH, which can be combined and used as a 16-bit register of CX. When combined, CL register contains the lower order byte of the word, and the CH contains the higher order byte. Instructions such as shift, rotate, and loop are used by this counter registers. Let us consider an example. The instruction loop start automatically decrements CX by 1 without affecting the flags and will check if CX is equal to 0. If it is 0, 8086 execute the next instruction. Otherwise, 8086 branches to the label start. Now moving to the data registers DX. This consists of two 8-bit registers, DL and DH, which can be combined together and used as a 16-bit register, DX. Here, DL register contains the lower order byte of the word, and DH register contains the higher order byte of the word. It is used to hold the high 16-bit result data in 16 cross 16 multiplication, or the high 16-bit dividend data before a 32 divided by 16 division, and the 16-bit remainder after the division. Now coming to the stack pointer and the base pointer BP. So SP and BP are used to access data in the stack segment, and SP is used as an offset for the current SS during execution of instruction that involve the stack segment in the external memory. SP contents are automatically updated, that is either incremented or decremented due to the execution of the push or pop instructions. BP contains an offset address in the current SS, which is used by instructions utilizing the base in addressing mode. And coming to the last index registers, that is the source index and the destination index. They are used in index addressing. The instruction that process data strings uses the SI and DI instructions registered together with DS and ES respectively in order to distinguish between the source and the destination address. So apart from this, there are flags. So generally a flag is a 16-bit register and that consists of 9 segments which can be used, and the remaining all are, that is the 7 bits are don't care condition. So the flag generally consists of registers bits like carry flag, auxiliary flag, parity flag, etc. They are all just used to give the condition of the instructions. And similarly, coming to the operand, which is there in the architecture, which cannot be used by us, are primarily used in order to during a very short span of time. That is, say for instance, exchange AL comma BL. So here there is a temporary register which will be used that we cannot use, but the register that is the architecture of the 8086 itself assigns a place in order to swap these two values. So we all know when AL and BL has to be swapped, there has to be some other temporary registers in between in order to put the value of AL into it and then to put it inside BL again. So now from the temporary registers, again the value can go into the value of BL can go into AL. Likewise, that is the operation of the operand and the flag registers in the architecture of 8086. So these are all about the architecture of 8086. So I'm stopping with a question. So what are all the general purpose registers? Name the general purpose registers. Thank you. We'll meet up in the next video lecture series.